Hello. So this is the third question of the June 2014 C34 exam. Let's start. Given that y equals cos 2 theta over 1 plus sine 2 theta, show that dy d theta is a over 1 plus sine 2 theta, where a is a constant to be determined. Now straight away, looking at the question, I know that we have to use the quotient rule because we have two functions of theta at the top and bottom of the fraction. Yeah. So the first thing that we do here, if you don't know what the quotient rule is, it's basically when we're given y as u over v, so dy dx is given by v times du dx minus u times dv dx divided by v squared. That's what we basically do. So let's see. Here dy d theta would be equal to v, which is 1 plus sine 2 theta, so 1 plus sine 2 theta times the differential of the numerator, which is cos 2 theta, so that is negative 2 sine 2 theta, minus cos 2 theta times the differential of the denominator, which is 2 cos 2 theta. From here. Okay, and then we will square the denominator, which is 1 plus sine 2 theta, so 1 plus sine 2 theta whole squared. Now expanding the brackets of the numerator, we get negative 2 sine 2 theta, negative 2 sine 2 theta, minus 2 sine squared 2 theta, minus 2 cos squared 2 theta, divided by 1 plus sine 2 theta whole squared. So here you can see that the negative 2 sine squared theta and the negative 2 cos squared theta, these terms give us 1. How? They don't give us 1, they give us negative 2. So we can actually take 2 out as a common factor, so we'll write it down as negative 2 as a common factor, and then write down sine squared 2 theta plus cos squared 2 theta. And from the identity sine squared theta plus cos squared theta equals 1, we know that this will equal 1, so we'll have negative 2 times 1. That's why this term equals negative 2. So what we get is negative 2 sine 2 theta minus 2, all divided by 1 plus sine 2 theta whole squared. Now again, we can take negative 2 out as a common factor, so we'll have negative 2, and then we'll have sine 2 theta plus 1, and then in the denominator. Now sine 2 theta plus 1 and 1 plus sine 2 theta are the same thing, so we can actually cancel them out. So this one goes into 1 and this one is cancelled. So we will be left with negative 2 over 1 plus sine 2 theta. So now you can see that we have reached what they asked us to do. So it's a over 1 plus sine 2 theta and negative 2 over 1 plus sine 2 theta. That means that a is negative 2.